Hi, I would like to go through one problem related to the test of hypothesis. I'm looking at the problem 9.28 of your textbook. I have to read the problem very carefully and see if I could determine what kind of test I need to use. So I read the problem, and the data actually saved already in the fast food file. And so the file fast food con- contain the amount that a sample of 15 customers spent for lunch at a fast food restaurant. So the data is given, and part A is asking at the zero point zero 0.05 level of significance, is there evidence that the mean amount spent for lunch is different from $6.5? And part B, it's asking me determine the p-value in part A and come up with its meaning. And part C, what assumption must be made uh, about the population distribution in order to conduct the t-test in part A and B. And part D actually is saying if sample size is 15, do you need to be concerned about the shape of the population distribution when conducting these tests? So let me concentrate on part A first. First, I have to decide what kind of test to use. I'm reading a problem, and clearly it's dealing with a population, one population mean, and then I have to decide, uh, since this is a dealing with one population, what kind of test to use. When we're dealing with test of hypothesis for the mean of one population, generally speaking, there are two tests could be used. One is z-test and one is t-test. Um, your book used um, standard deviation. It says if the population standard deviation is known, use the z-test. If the population standard deviation sigma is unknown, use the t-test. I like to just look at the sample size. I'm saying if the sample size n is more than equal to 30, I use the z-test. Otherwise, if sample size is less than 30, I'm going to use the t-test. So if I go back to my problem, clearly I'm taking a sample size of 15, and that obviously is less than 30, so I'm going to try to use a t-test. Secondly, it doesn't say anything about population standard deviation, so it's reasonable to assume that the population standard deviation is unknown, and that's another reason I need to use a t-test. Now, I would like to use StatCrunch. Since some of you you have a Mac, you cannot use Excel. So I like to go to the Pearson site, and over there I try to access StatCrunch. When I try to do that, it takes a little bit time, but eventually it's asking me if you want to use the data set from your textbook. And that's what I'm going to try to do. I'm going to go there, and it takes a little bit time, but eventually it provides me the list of chapters. This problem is in chapter 9. So I'm going to go there, and its name of the file was fast food file. So let me try to access it. It's going to try to access it and right away put it over there. And so I have the data right now in StatCrunch. And now I would like to try to run a stat test. And so I'm going to go to stat. Underneath that, I'm going to go to t-test. It gives me t-test for one population, one sample, two population, two samples, and so on pair. So I'm going to go to the first one. And then it says if the data is given, or if summary data would be given, or power and sample just would be given. So right now I have the data in front of me, so I'm going to go to the first option. Now, when I um, select that, obviously I have to select my variable or my column. It's the cost. And then I got to try to find out what kind of hypothesis I have. And it's sometimes it's very confusing to determine which kind of hypothesis you have to perform. I guess the best way to deal with it is going to going back to your problem and read it. Uh, uh, the, look for some keyword. if the problem is asking you for something is different from, as something has changed, uh, these wording imply that you need to use a two-tailed test. So here I am reading the first part. It says, is there evidence that the mean amount spent for lunch is different from $6.50? So obviously this is a two-tailed test. So let me go back to StatCrunch and let me go back there. And now my anti-HO, I have 6.50, and under alternative, it's not equal. If I had a different type of problem, I could probably have a different alternative. It could have been less than or more than. Right now, I have not equal, so I'm going to choose that one. And that's all I need to do, because if I ask for calculation, um, going to go through and basically it's going to tell me, okay, under HO, you have mean equal to 6.5. Under alternative, you have a mean is not equal to 6.5. And it has gone through this, come up with the sample mean of 7.09. Um, and basically, if I round it up, that becomes like a 7.1 if I want to do it manually. And my standard, basically, I could go through the testing. Eventually, my statistical test is roughly 1.64, roughly. So I can go through these and say, okay, let's make a decision. Now, let me again go to PowerPoint and try to do this. Um, I need to find out under HO, I have mean equal to 6.5. Under alternative, mean is not equal to 6.5. I have 14 degrees of freedom. Remember, degrees of freedom is n minus 1 here. And eventually, the, that would be 14. I need to divide alpha by 2 because of the uh, situation I have. I have my alternative not equal. Whenever you see alternative not equal in chapter 9 and 10 of your textbook, always divide alpha by 2. And now, when I divide alpha by 2, so I need to go to with 14 degrees of freedom and 0.025. Let me go to table with 14 degrees of freedom and 0.025, the corresponding value is 2.145. So my T of table is 2.145. Let me go back to my PowerPoint and basically uh, I come up with critical value for T plus minus 2.145. So I could construct my rejection region and my acceptance region. Anything more than 2.145 to the right of that is in the rejection region. And anything less than minus 2.145 also in rejection region. And in between minus 2.145 and plus 2.145 non-rejection region. So if I use this statistical test manually, this is a formula I have, and it's a little bit different in terms of number. I think I have 1.64 when I was trying to do it using um, StatCrunch. It's very close, so it's not that much different. And now I'm going to put my statistical test here. Obviously, it's non-rejection region, and now when I'm comparing these, I could come up with the decision: do not reject HO, and I could conclude insufficient evidence that the true mean lunch expense is different from 6.5. So statistically speaking, the value we got for our sample mean, which is 7.1, was not really far from what we are testing for, which is 6.5. So we say we couldn't find enough evidence to determine that uh, the population mean is different from 6.5 based on this sample. And now a couple more issues I would like to go through it, and that's related to alternative. You really have to read the different problem very carefully and find out what kind of alternative you're dealing with, especially in chapter 9 and also in chapter 10. Uh, Always what I do under the show, I use equality. In this case, I say mean equal to 6.5 particular value, and then I read the problem. If the problem asks me, oh, based on the information we have, we think that the mean of population is less than, then right away I know my alternative is going to be less than, and it's going to be lower tail kind of case, left tail. On the other hand, if I read the problem and somehow the problem indicate that, oh, we are testing for mean more than 6.5, obviously that's larger than 6.5, then I have to go and try to go to the alternative hypothesis mean more than 6.5. And now when I come up with like a critical value, as long as my alternative is less than, eventually I end up on the left tail. And my rejection would be to the left of my statistical, my table value, let's say in this case t table. On the other hand, if my alternative is more than, anytime I have alternative more than, then my rejection region would be on the right side. Anything more than this particular value would be in rejection region, while um, my non-rejection region would be on the side. Uh, I know test of hypothesis generally is very confusing topic, but few hints in this regard is helpful. One would be you read the problem and find out regarding if it's one population or two population or more than two. And the second thing you do, you gotta again read and see if it's about the mean of population or it's about other thing. And then you have to decide about statistical tests. So that's the third thing. In this case, so we look at the sample size. If sample size is small, we go with the t-test. If sample size is large, we go with z-test. And fourth thing, important thing, is deciding about if you have a one tail or two tail. Again, you have to read the problem and see what the problem wants to establish. If the problem wants to establish that the mean is different from, right away you know the alternative should be not equal. And that implies in chapter 9 and chapter 10 that you need to divide alpha by 2. On the other hand, if they want to establish that mean is more than certain value, then you know you have one tail and it's going to be right tail. In some other cases, maybe they want to establish that mean is less than some number, then that would be left tail. So these four issues are very important to consider when you're dealing with test of hypothesis. And if you try to go through these steps, I think you have a better chance of coming up with the right answer. Thank you for watching. And if there is any issue, please let me know.